Okay. Did you attend this training lab? How to build end-to-end physical AI systems for robots?
That is full conference.
Oh, and this one as well.
Which one?
Beyond 3D.
Yeah, that was also full conference.
Bruh. Training lab. All right, we are live.
All right.
So, welcome back after a short 1 week break of streaming. Um, we were at the conference
Mm-hmm.
SIGGRAPH 2026 LA, which was majorly sponsored by NVIDIA and some other companies like OpenAI and
Dell. I got some.
Dell.
Yeah.
Yeah, even OpenAI. Even what do you say? There were like some companies that were like
Mm-hmm.
part of the Inception program at NVIDIA. So we got a lot of information. We got a lot of contacts and networks, and we got a lot of direction from investors and peers in the same industry and field. So overall, it was a good conference. Unfortunately, I had to miss the first 2 days because of Delta.
Because of
Um,
Canadian wildfires, bro.
Canadian wildfires. I don't know if it was the Canadian wildfires, bro. I don't know. Because the flight before our flight took off. I don't know. And yeah, so basically, the first day was missed, and the second day was missed as well. There was a NVIDIA keynote. Aditya, if you want to talk about that, if you have any notes or anything, recordings or notes that you might
I
want
do
to
have,
share.
I do have the recording. I can share some maybe images. Wait.
Did you post about it?
Yeah, I did post it about it. Yeah, 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 definitely. Like if you go to my LinkedIn and look at my profile, you will be able to find it. I did post it about it. So anyone that is really interested, you can just look at my post. It will give you a
Mhm.
brief about it. Uh, more next. Yeah, this is the one. No, yeah, yeah.
This one?
Oh no, the other one.
Which
Where I,
one?
yeah, this one.
Hmm.
So yeah, like they added the S5 that is more for people, but the most important thing was the 200 terabyte to 200 megabyte compression ratio that they created for massive physics
Mm-hmm.
simulations. This was the key highlight of the whole keynote.
Mm-hmm.
And if you go through the images, I think you can also find what I'm talking about. Like if you go to my go through the images that I have posted over there in the post.
Mm-hmm.
Yeah. So like if you open this image, you would be able to see the architecture of their model. So they are using
Mm-hmm.
basically auto regressor and diffusion at the same time. So auto
Mm-hmm.
regressor helps you to predict the next forward motion that a
Mm-hmm.
common model is made for, and the
Mm-hmm.
diffusion is used to generate those images of those forward motion, and
Mm-hmm.
they do it in a sync. Like I'm just giving you
Mm-hmm.
an overview in layman terms, right? I'm not going into detail. Uh, and if you move to
Mm-hmm.
the next image, I think we might be able to find the other one as well. Let's move to the next one. So yeah, go back. Like if you go back, so this is really important. Like this image describes the scale that the world cosmos model are working on. So the image that you see over here is a render
Mm-hmm.
in world cosmos model. They are simulating each and everything, like each and every freaking particle that exists on Earth, air, temperature, how air
Mm-hmm.
and winds move across the globe, right? Basically,
Mm-hmm.
the whole world, but on a scale. And this is what they're talking about regarding the 200 terabyte data, right?
Mm-hmm.
So they have used Era 5, as you might remember when we were working at the Oceanic Lab at Florida State.
Mm-hmm.
They did have
Yeah.
5 data, and
Mhm.
that data is like seven-dimensional data. So they are taking
Mhm.
all parameters and trying to predict each and every motion on the earth that exists
Mhm.
across seven or 10 variables. So that is like
Mhm.
temperature, precipitation, and how those variables, when you like put everything together, and how it
Mhm.
affects the climate and everything. So now we
Mhm.
move to the next image, like click next two times, and then yeah, one more time. Again, I think I don't remember. Oh no, I think I did not uploaded that image over here. But that image basically described the compression ratios. So they have 1 million parameter in their model, and they're compressing it
Mhm.
to basically one. That was the compression ratio that they talked about. This is not.
Oh, there is a person in our chat. No, we are not back in India. We're back in New York. Like I'm back in New York.
Yeah, I'm back in Florida.
Yeah.
Florida, baby.
Mhm.
Right. And this is
So
a
what was this Jupyter Notebook data augmentation?
So this notebook basically defined was a hands-on experience with how you can use World Cosmos model to predict
Mhm.
a lot of things. So over here you can see the edges, depth, and segmentation, and the blur. So all those things are the variables that you can input
Mhm.
into a World Cosmos model when you're trying to do some kind of prediction. So the above video, like I can share, if you go onto our WhatsApp group that we had,
Mhm.
I posted about like what those videos were. So above the above video was basically predicting a landslide on a road, like rocks are tumbling down,
Mhm.
and how the
Uh-huh.
physics works with the rocks and along with the gravity.
Okay.
For this,
Let me see if I can show that. Oh yeah, I found it. This one.
yeah, yeah, this was the one. So like if you are able to play it,
Yeah.
so now you will see uh, a landslide animation and rocks tumbling down,
Yeah.
right? And the gravity and the physics that the model
Mhm.
is applying. It's not the perfect one, but like if you fine tune it with enough data,
Mhm.
with enough maths, basically physics,
Mhm.
we can get a close to like 99% or 98% simulation
Mhm.
accuracy, and that will basically help us train our robots in those kind of simulations,
Mhm.
and maybe use other reinforcement learning algorithms to predict more
Mhm.
scenarios and then train our robots accordingly. That hey, I think this is not a good path to go with, and then we use
Mhm.
reward function.
Nice.
Yeah, this was the hands-on lab basically.
Oh, hardy.
SIGGRAPH, bitch.
All right. So this was the architecture that they were talking about in
Yeah.
Cosmos.
Yes,
Is
yes.
this like the new architecture or is this the original one?
So this is like the new architecture. I think this is the original one, but they're giving us like bit more information about it, right?
Mhm.
Like a keynote and presenter note. Like they are using basically
Very dark.
already using the same architectures and the algorithms that existed. Like autoregressive algorithms did existed, and also the stable diffusion model algorithm. But they have basically merged both of them into a single model, and that's how they are.
Mhm. What is mixture of transformers? Is a model architecture that combines multiple transformer blocks into a unified system, enabling it to use the appropriate processing strategy for the input, task, or generation objective while maintaining a shared representation space. Hmm. Did they use mixture transformation? Mixture, yeah, this is the one. Mixture of transformer architecture. Let's see. Yeah, so basically, what our goal would be. Okay, so that was day two, right? I think. And then on day three, which was a physical AI day, we basically attended a talk on world models, the frontier of physical AI unlocked by graphics. We attended OpenUSD for AI agents, model driven workflows, building sim ready 3D worlds for physical AI. Um, so this was by Palatial and Lightwheel.
Mm-hmm.
And this was one of the most intriguing talks over here. OpenUSD based assets to prepare 3D worlds for downstream physical AI workflows. Lightwheel was one of the most impressive companies that are doing this, even Palatial.
Yeah.
Why do they? They don't have a website?
Light wheel?
Palatial.
Maybe.
I think this is the one. Oh, okay.
Ooh, nice animation. Oh, this is your mouse moving it. Oh, crazy shit.
Yeah.
We could have something like this on our website as well.
Yeah, we should.
Interesting.
This is what I wanted to do, bro. Like, this was what I was envisioning, but it's fine.
Wait, how is that rotation? Oh, motion. Wait.
That's automatic.
Oh, that's automatic, right? Oh, okay. I will. Hmm.
Yeah, so Steven was the guy who gave the talk. It's pretty insane. Mhm. Asset library is pretty good as well.
What the fuck?
Hmm. Medical equipment. It's for ISAC sim generate variant. Add to card. Okay, it's free. So I'm guessing these are like asset libraries that you can download.
Hmm.
XYZ, let wireframe, collision. Uh-huh. This is the asset hierarchy. Oh, nice. I can edit it with what? Validation, broad test. One time, one call you will see me go. Oh, but the website is pretty insane. This is like almost USD view actually.
Yeah. I did share you another online compiler. Like it's not that difficult. There is an open source library that you can use to render it.
Mm-hmm. One asset infinite variants. Okay. And for editing, you can do parts, I guess. Okay. What is face unit wireframe? Oh, so in the wireframe, I think you can see the mesh. Solid. Lit. All right. So yeah, this was like the second day or the first or third day on the talk for that stuff. How to develop real-time 3D digital twin for rapid engineering design. I think this was by Abigail. What did we do over here? Did we attend this or no? We attended this, right?
What time was it? Yeah, I think we did attended it.
Codex libraries, AI physical models, and agentic engineering too. Oh yes, yes, yes. I remember. Yes, yes. Are leveraging NVIDIA technologies to enable real-time digital twins that accelerate design iteration and improve engineering. Bro, where are your notes? Where are your...
Dude, I have to take the voice notes out. I have not yet. I will do it today. Those are in
Uh,
my recordings. Like I didn't over here. Voice
did
note.
you not generate any notes from that?
Not yet. I haven't got time, but I will do it.
Did you post about day three then, or did you
No,
not?
no, I have not. That is the thing. I have not posted about day three yet, and not.
But why, bro? Why?
I have to, dude. I will post it today. No worries. I will post it like a recap of both.
Edmar Menziva. Yeah, I'll post this picture as well.
Yeah, post it. Admire the OG. He's the OG guys. Make sure to connect with them
Yeah,
and mention our
Jonathan.
channel. You might get in.
Lightfield. Thanks for coming to the party.
Yeah.
Lightfield commented on your thing, bro.
Yeah, I know, bro. I know. Even I think the VP of Global Sales did connect with us.
Uh-huh. Nice. I see. Oh, you're a founding engineer at Stealth AI startup, Physical AI.
A stealth AI startup could be anything.
I know. Sim ready objects ready to drop in. Glacial is pretty insane, actually. Glacial is way ahead of its time, I guess.
Mm-hmm.
Asset library. Yeah, we already saw this. Palatial cloud. So yeah, that was pretty much the day, physical AI day, I guess. And then on Wednesday, we did a lot of hands-on labs where we were doing some ISAC simulations. Um, but yeah, I think that is a good recap. And then yes, on Thursday we I did like this. Oh, okay. So this is the architecture I am guessing. I'm
Yes,
guessing
that's the architecture.
mixture of transformer architecture. let me start a new project where we learn about where is world foundational models. And let's add mm, 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 this architecture here or different original.
Let me just try to see if.
Oh, baby tonight. Mm, oh, fine.
I'll be back, bro. Like in 5 minutes.
Okay.
All right.
Yeah. So let me open Excalibur as well. We need to plan out, you know. So this was the initial layout of the prototype that we are gonna do. Operate the scene using Omniverse technology. Read this, bro.
Wait, which part are we at? Stage one?
Let me, one second, let me,
Stage one, I guess so.
I'll put them in a correct sequence.
Initial prototype Houdini Omniverse Asset Cosmos Pipeline. Consider robot being trained to work in warehouse. Stage one, create asset in Houdini. Okay, okay, okay. All right. And then
Stage two is
represent
OpenUSD.
world with OpenUSD. Okay, stores, hierarchy, transforms, materials, variants, references, payloads, physics schemas, and semantic metadata. Stage 3, operate the scene using Omniverse technology. Okay, we have runtime. We are going to use OBRTX as well, I guess so. That is not over here. RTX
Mm,
rendering, physics simulation, GPU acceleration, and application services. Simulate the robot in ISX Sim. Stage 4, import, configure, attach, run physics, connect ROS2. What is ROS2?
Robot operating system.
Okay. Do we have that from NVIDIA or we are going to work on our own?
That is something different.
This is what I
I
was
don't
talking
know.
to my friend at Amazon that this is what we are trying to do as well. Create our own robot operating system that can help us connect.
No, bro, I don't think we need to reinvent the wheel.
No, it's not like not reinventing the wheel, but uh, making the wheel so robust that people start using our wrapper more than anything else.
Documentation, yeah. That was that. And then execute robot tasks, record demonstrations. And the fifth stage is using Cosmos for foundational models.
Hmm. And stage 5 is
I'm guessing this curate training data means curating synthetic training data, which
yeah,
will be generated using
Isaac
Cosmos.
Sim. No, it would be generated through Isaac Sim, bro.
ISACSIM, you use the data, bhai. I don't know.
We can generate the demonstrations. Right? That's
How
how,
is ISACSIM gonna generate synthetic data?
because you're gonna simulate your environment. Like it will help you generate the object models and everything that your world Cosmos model will train at.
That is not synthetic data.
That
Synthetic
is
data is
synthetic data, bro.
basically,
So
bro, synthetic data is basically a robot performing a task and failing at it or succeeding at it in
it
a certain
depends. It
manner.
depends, dude. It depends completely on what kind of data. So okay, if a robot is trying to perform a task, right? So the object. So like if it is an object that you do not have in real time, right? Then that object can be rendered inside that Isaac sim, and then that would be a synthetic data as well.
I don't know. Okay. And then look at this. Generate scenario variations, generate possible trajectories, reason about physical outcomes, curate training data.
Okay.
So this would be synthetic data, I'm guessing.
Mm-hmm.
Because that is like generated purely based on the previous states.
Mm-hmm.
train robot policy simulation data plus real robot data plus world foundational model generated data. So WFM generated data is synthetic data,
Mm.
and that will be put in the vision language action model or reinforcement learning policy, train robot behavior, deploy and improve reinforcement learning policy. Real robot produces failures and new observations, digital twin. So this is the main deployment loop
Mm-hmm.
where well, like the real robot will what the deploy produce failures and new observations. We will put that digital twin in ISAXM. It will reproduce failures in Houdini. Houdini will add missing environment variations. Cosmos generates and reasons over new scenarios. Policy training improves behavior, update robot. This creates a continuous development loop. Mm, mm. So, where do we need to start from? We need to.
Assets and Houdini. But we need a license for Houdini, right?
I already have Houdini Apprentice, so that's not.
Mm-hmm.
No, so I think we need to first understand Cosmos and we need to read the research paper for Cosmos.
Hmm.
Because Houdini is just an option. Like we can also use something different, like not use Houdini and we can use something else as well.
Mm-hmm.
Houdini is just a digital PCC tool.
Mm-hmm.
Hmm. I think I did have this discussion with.
Oh.
Hmm. This was the one that I was talking about.
The complete Houdini, OpenUSD, Omniverse, Success Cosmos pipeline. Procedural word generation. NVIDIA Omniverse, ISXM, Cosmos, World Foundation Model. Policy RL training. Hmm. So like, have you figured out what is the sample data we're gonna use?
No, I have not figured out
So,
anything.
so let's go to Omniverse assets. Like, let's do a search for that, and let's
Mm-hmm.
figure out like some pre-rendered scenes, maybe of
Mm-hmm.
an Amazon warehouse from where we can get started. I would say.
I see. One second. You want me to go where?
Go to NVIDIA Omniverse asset, like do a search like that. I think it will give us something. NVIDIA
NVIDIA Omnia?
NVIDIA Omniverse assets.
I know what that is. Like I have downloaded. That's what I downloaded from
Yes,
the for the kitchen set.
yes. So yeah,
Yeah,
like
I
we
know.
can take we can take like one of a minimal example like that. Or we can use the commercial asset on industrial.
But what do you want to do with that?
So once we have the asset pack loaded, then we would have our like
Mm-hmm.
like we have the like first step is to collect figure out what data we're trying to use, right? Like in the workflow, we have to first figure out what is the assets that we will be using and what world we would be rendering in Houdini. That's what it
Mm-hmm.
is saying. And then uh, if you go back to the image,
Mm-hmm. Uh, yeah.
right? So the generate environments and layouts, and so we already have an asset. Now build shelf, rooms, road. So we already have that as well. Now create collision geometry and level of detail. So this is, I don't know, like this would also, I think, come under that asset zip that we are going to download, and I think the
Mm-hmm.
semantic tables will already be over there, and then export the reusable asset scene. I think this is everything is already taken care by that asset zip.
Mm-hmm.
That's what my assumption is. And once we have that, then we can basically directly open our assets into our Omniverse or the Isaac Sim Lab, where the only thing we have to do is to get that robot file that we did it in the hands-on lab. They had a robot.usda. I do not remember the
Mm-hmm.
file name, so we have to import that into the environment.
Mm-hmm.
And then since all the physics and everything is already applied into that environment via that zip, uh,
Mm-hmm.
we can basically connect Blender, right? We can use Blender
Mm-hmm.
or either Isaac Sim to with our OVRTX library from Omniverse,
Mm-hmm.
and then connect all the three things, and then connect it with our Codex agent or Cloud Code agent to
Mm-hmm.
perform some kind of animations. Like for example, the robot is picking up something or
Mm-hmm.
dropping off something from the shelf. So I think this is where we could get started. Like this would be our first steps to reproduce what we have learned in the SIGGRAPH,
Mm-hmm.
right? And once we have completed that part, then we will focus on the fifth one, that is
Mm-hmm.
Cosmos World Foundation models, right? So for now, I think Houdini is like out. Houdini is out of the way because we already have that asset dot zip, right?
Mm-hmm.
So the only thing that matters to us right now is loading the asset successfully in the ISX sim, and then connecting it with our Cloud Code agent via the MCP tool and the skills that we have on the GitHub official GitHub repos.
I don't understand that. What you're trying to say?
Which part?
Like, where are you? Where do you like? What will be our first step now? Just tell me
Uh,
that.
First step would be loading the ISX sim.
Okay. And then once we have launched ISAXM, then
Then we render that asset file, the whole industrial package that we have, onto that.
okay, and then
And then we add a robot, zip
okay.
robot asset from somewhere else, and
Mm-hmm.
render it in the ISXM.
Mm-hmm.
You get it now, like basically doing the same thing that they taught us in our hands-on lab, but in a different world. Like we are basically recreating the uh, whole hands-on lab, but on a different environment and using different tools.
Mm-hmm. We want to. Mm, there are. Let's see. Damn, dude, I forgot to add my SIGGRAPH reimburse in the reimbursement things. That SIGGRAPH ticket or like
Oh,
I forgot to add that. Damn, I just remembered, but it's all right. I could have added like that. I missed 2 days, but I paid for
100 days
5 days.
each. 100 days, $100 each. My bad. 100 days each. I'm sorry.
Yeah, it could have been more $200, but
Hmm.
let's see. Okay, let's see what it answered. Existing assets: Blender, CAD, OpenUSD, Isaac Sim, Physics plus Sensors plus Robot, Isaac Lab, Task Definition Parallel, RL Training Libraries, Trained Policy Simulation, Simulated Evaluation, and Real Robot. Core Simulation, Basic Policy, Reliable Evaluation, Domain Randomization, Synthetic Perception or Demonstration Data, Real Work Data, Cosmos Augmentation. Large scales is distributed training. What is the alternative to training? You do not need running for version 1. Okay. Okay. Okay, this is the core architecture that it is defining. Let's see how that looks in Excalibur.
What's this?
It's the architecture of the pipeline that we're trying to build. Asset creation is number one. Sim ready preparation is number two.
So for us, we already
ISACs.
have the asset. That's what I've been saying. We do not need to create an asset right now.
I know, I know.
Yeah.
I'm just trying to see if, like, what is the part we need to focus on first.
I think
And don't say ISACSIM.
just loading the ISAC sim with our asset file from NVIDIA and try to see what we can do and what are the things that we can play with. That would be our first goal, I would say.
Bro, we did open the ISACSIM the other day and we did have a environment over there.
But we did
But
not loaded this one, right? And we did not even do connected our cloud code and MCP tools accordingly, and the way
okay.
they showed us on our hands-on lab, right?
How did they connect it?
So if we go to GitHub, I think they do have a skill set over there completely.
Send me the link.
Yeah, let me just. Oh, I'm trying to go through that only. GitHub, ISAC. Yes, sir. And cursor skills. Oh yeah, there we go. Yeah. So I'm gonna send it to you on iMessage again. And from over here, we got it. Yeah, I have sent it. I have like sent you on iMessage so you can take a look and open the GitHub repo. Now, if you go to Claude skills, up above on the top above, yeah, yeah. So this is the one ISXM remote that we have to use, and it covers everything. So this is the Python server that they will have in the, like, we have to clone this repo,
Mm-hmm.
or it will
Mm-hmm.
be directly inside the ISXM that we are gonna load, and this server
Mm-hmm.
will basically help us connect to our ISXM, and then we can prompt and command like whatever we want inside the ISXM as needed.
Mm-hmm. Mm-hmm. Okay. Sim ready preparation, ISAC sim, ISAC lab tasks, reward, okay, replicator, perception trainer, RL trainer, integrate ball, yeah. Hmm. Hmm. So let me. Okay, I think I get the idea now a little bit.
We have to set up like spin up our Brave cloud, and then probably how much does ISXM need for VRAM? I just need to figure out what ISXM VRAM configuration, bro. That DJX Spark, I don't know, man. It texted my that's 16 GB fuck. Oh fuck! It requires at least 16 gigs of RAM. So yeah, we are fucked. It was.
All right, I'm asking it to generate a document for a simple project, which is going to be just a robot
But I
arm
would say
picking
give
up
it, I would say give that asset file look that downloadable asset packs so that we don't have to
give what,
the asset packs that we have available.
but what asset pack, what
The links
the
to the asset packs, downloadable asset packs on your yeah, this one. Just give
to
this one.
chat GPT
Yeah, then it will help us
to
to
do
select.
what?
It will help us to select what asset should we go with.
Let's see what it says first, and
Mhm.
then we'll do that. So what I'm thinking is we should split our time on the, well, like when we are streaming, we should split our time like a couple of hours we should
Mhm.
spend in reading this research paper, Cosmos World Foundation model, because this will give us a good idea about how the thing is done actually, and then other half should be uh, you know executing the project actually
Mhm.
in like the Brev instance and stuff like that. Hmm.
Mm.
It's still planning it out. I don't know why is it taking so long.
Oh, dude,
Oh, what the fuck?
someone at YouTube just viewed my profile.
Yes.
I think even YouTube is watching us. Holy shit.
Hmm. Bro, what the fuck? Why is it taking so long? Still going? Still going.
Dude, just stop it and restart it. I think the model is stuck.
Matching your learning goals, clarify and pages to keep it simple. Let's start read. Okay, so this was that, and then so Isaac Sim is responsible for producing simulator world. Hmm. Hmm. Okay, Isaac Sim is responsible for producing the simulated world, physics, and sensor observations. Isaac Lab is responsible for defining and orchestrating the robot learning task. The RL framework is responsible for updating the policy model. Replicator produces labeled perception datasets. Mimic and SkillGen produce robot demonstrations. Cosmos augments or generates learned visual and scenario data. Houdini is an optional upstream world generation tool, not a requirement. Hmm, I see. Bro, what the fuck happened? I'll give it the downloadable asset. Oh, USD? What are USD example datasets? 3.2 gigs, no way.
Bro, I have to fucking sign my lease. Yeah, let me do it right away. Cheryl. $800. Landlord's following address. Tenant. DocuSign. What the fuck?
Okay, I think now it's gonna create a documentation. Hmm. Bro, hopefully the fucking Delta people send the
Dude,
reimbursement. Otherwise, I'm fucked.
no, dude, you won't be fucked. Don't worry.
I'm not fucked, but yeah,
No, no, they will definitely send it. I know, I know.
yeah.
Okay, bro, I'm signing the lease documents,
I see.
and it's done. I officially extended my lease.
What if you need to break it?
If we need to break it, then we break it. Sublease and all those stuff. I don't know, man.
Mm.
What you doing on this? Oh, the
Oh,
notebook.
the Jupyter Lab is still working. Nice.
Oh.
So this is the Gaussian splatting thing, like the thing I attended.
Mm-hmm.
Let me see if it's still working. Yeah, it's still working. Let me see. New generated viewer and running headless mode. Oh, okay. Yes, it's still working. Nice. This is the Gaussian splatting of the data set.
Mm-hmm.
You see these three images. So there are in total, I think, let me see how many, 182 images.
Mm-hmm.
And these were ran through a set of programmatic functions which convert, like which process like them into like points,
Mm-hmm.
point cloud.
Mm-hmm.
And then,
So what are point clouds? Like the dots that we are seeing?
yeah. So they make up the whole scene.
Mm-hmm.
You see this Gaussian splat.
Mm-hmm. So explain me what is a Gaussian splat first of all.
Gaussian splat is basically the 3D model of any environment
Mm-hmm.
that you convert by creating three-dimensional points of the surface of all the data that is available to you in a image data set.
Mm-hmm.
So, like for instance, uh, with these 182 images, these 182 images were taken. All these images were from a different angle.
Mm-hmm.
So these different angles basically make up all the surfaces of a singular point in this data set,
Mm-hmm.
in this environment,
Mm-hmm.
which allows us to basically, you know, view the whole thing in like three
Mm-hmm.
dimensional space.
Mm-hmm.
And then this is how you are going to transfer any warehouse or like any environment into like ISACSIM as well. So you'll first convert it into Gaussian flat, and then you'll convert this Gaussian flatting file, which is the .ply file, into OpenUSD using a file format plugin or a standalone converter or some sort of ETL process.
Mm-hmm.
So this was the idea behind that actually, and then let me see if so look at this FVDB. So this is the framework that the person who was explaining, Zoe,
Mm-hmm.
she and her team has created this framework, FVDB framework, which is like which. So over here you see like you can we can see that this is the environment.
Mm-hmm.
So if you see the original image over
Mm-hmm.
here, so this is the original image,
Oh.
right?
Mm-hmm.
This is the original, the town or whatever, like a sample town or something, right? And so there were like 182 images like this from like different angles
Mm-hmm.
all over like they captured this via a drone or something, and
Mm-hmm.
then basically they converted
Mm-hmm.
these images into the Gaussian splat,
Mm-hmm.
right? Like this.
Mm-hmm.
And then what FVDB does is that is like a framework.
Mm-hmm.
They basically so over here you can see that this Gaussian flat is very lossy, right?
Yeah.
Like you can see that okay, it is the environment that we need, but it is like very lossy right now.
Mm-hmm.
Like you can make out the environment, but it's still not what we would want.
Uh-huh.
Yeah, right. And I think wait, let me see. Yeah, so these are all the camera angles. These green dots are all the camera angles, I'm supposing.
Uh-huh.
Mm. So basically, what FVDB does is it basically improves this Gaussian splatting by running some sort of algorithm
Mm-hmm.
where so this is the render image,
Uh-huh.
this is the predictor image. So this computes the loss,
Mm-hmm.
and then it feeds in the truth, like ground truth image, like one of the images over here,
Mm-hmm.
right? Like for example, if they want to improve this part, so they are going to feed the ground truth image like this image directly,
Mm-hmm.
along with the Gaussian flatting thing over here, and uh, and then they're going to update the 3D Gaussians.
Mm-hmm.
So this is what okay. So here they are importing FVDB reality capture transforms as FV transforms. So let's run that. So you see there is a training loop that has started over here,
Mm-hmm.
right? And then yeah, I think now it is gonna be better than the above one.
Mm-hmm.
Yeah, so see this is like much better than the previous one.
Oh. So the magic is with the FVDB
Yeah, it
algorithm.
is an algorithm.
Mm.
So let me actually compare these real quick. Or we can only run one thing at a time.
Mm-hmm.
Okay. So this is what that did, and then let me run this. Higher resolution and larger quantity of images will cause training to take longer. Our optimizer was created with several different parameters. The effect when we save the model, how often slats are refined, and more.
Mm.
There are many more parameters you can vary for training beyond these few.
Mm-hmm.
Mm, you will use the command line interface tool to call FRGS for easy use of Gaussian splatting tools. To learn more about FRGS, please see reconstruction on CLI with FRGS. Page not found. Damn. Now we'll run the reconstruct script with the help to see all the possible augments and parameters.
Mm.
I don't know what it did. Try changing and adding parameters to see how they affect training. To stop run early,
Mm-hmm.
you can click the square button at the top of the notebook to interrupt the kernel. Okay, visual Gaussian splatting. Hmm. I don't know why it's not working anymore.
Deep Learning Institute of NVIDIA.
I think this plain emoji
Mm-hmm.
um, is basically saying that there was a picture taken from all these points.
Mm.
Let's see what it did. Did it do anything? I think it's still training.
Mm-hmm.
Oh, error. Model initialized 168,000 Gaussians. Let me see what's going on. But yeah, that was the idea over there.
Mm-hmm.
And then in this one, I think we did segmentation,
Mm-hmm.
which was basically like if you have one image from left side of an object and then another from the right side,
Mm-hmm.
how will the middle part look for that object?
Mm. I
That is basically the algorithm over here. That's what I'm remembering, but
see.
I'm not sure.
Interesting. Hmm.
I don't know. Oh, hmm. Bro, this is still running. What the fuck is going on?
Dude, what is ChatGPT doing?
Bro, it created the project documentation, but I don't know why it's not able to finish.
It's singing too hard.
Hmm. I don't know, bro.
Okay, so I know for tomorrow's plan, we will work
Mm.
focus on spinning up the Brev cloud and loading
Mm-hmm.
the access.
Okay.
And
Oh, finally. Fucking. Oh, yeah, it's saying the same thing.
hmm, visionary, visionary.
Bruh. Okay. Pilot task. Franca end effector reach followed by optional. Oh, this is what we did, right? In the lab as
Yeah,
well.
yeah, yeah.
So yeah, I think we should focus on getting this set up first, well, tomorrow. Or do you want to do it today?
The thing is, dude, we can do it today as well, but it's gonna
Mm.
cost us that storage part. So that's why I'm planning that, like, to save on money, and probably, I think by this week I will have my uh, DJ Spark setup as well.
Mm.
That's my hope. That's why I'm not trying to spin it up. Like, I'm not that proactive with spinning up that thing because it's gonna
Hmm.
cost us the storage, right?
So
So
this is the mental model. OpenUSD assets we are going to download from that site,
yeah.
and then we are going to load this USD stage in ISAC sim in that Brev cloud.
Mm-hmm.
And then after that, ISAC lab defines observations, actions, rewards, resets in parallel environments. And then collect rollouts and update policy weights. Saved neural network policy for replay and evaluation.
Mm-hmm.
Whereas synthetic data during the online RL, ISAC sim, and ISAC lab generate synthetic experiences continuously. Observation, action, next observation plus reward RSL. RL stores short rollouts, updates policy, requests, new experience, replicator style image data sets. I don't understand what that is. Okay, train the Franca Panda arm to move its end effector toward randomly sampled target poses using built-in manager-based environment. Mhm. Okay, I think we can get started with this project tomorrow.
Mm-hmm.
Can we use NVIDIA's OpenUSD sample content? Yes, with the correct expectation. This downloadable sample packs are useful for eliminating custom asset authoring during. Mm. Hmm. All right, we can get started on this tomorrow. So,
Okay.
like, we, I think we should first spend some time reading this as well, bro. I think it's very important.
Okay.
Cosmos World Foundational Model Platform for Physical AI.
Physical AI needs to train digitally first. It needs a digital twin for itself and the policy model and a digital twin of the world. The world model. In this paper, we present Cosmos Foundation Model Platform to help developer build customized world models for physical AI setups. We position the world model for downstream applications. Our platform covers a video curation pipeline, pre-trained world foundation models, examples of post-training of pre-trained world foundation models and video tokenizers to help physical AI builders solve the most critical problems of our society. We make Cosmos open source and our model open weight with permissive license available by Cosmos Predict 1. Introduction. So physical AI is an AI system equipped with sensors and actuators. Okay. The sensors allow it to observe the world, and actuators allow it to interact with and modify the world. It holds the promise of freeing human workers from physical tasks that are dangerous, laborious, or tedious. Well, several fields of AI have advanced significantly thanks to data and compute scaling in recent decade. Physical AI inches forward. This is largely because scaling training data for physical AI is much more challenging, as the desired data must contain sequence of interleaved observational actions. These actions perturb the physical world and may
Where are
cause
you reading exactly?
introduction.
But where?
Like yeah, over here.
Oh, this part. Okay.
These actions perturb the physical world and may cause severe damage to the system and the world. This is especially true when the AI is still in its infancy, when exploratory actions are essential. A world foundation model, a digital twin of the physical world that a physical AI can safely interact with, has been a long sought remedy to the data scaling problem. In this paper, we introduce the Cosmos World Foundation model, WFM, the platform for building physical AI. We are mainly concerned with visual foundation models where the observations are presented as videos and the perturbations can exist in various forms. And as illustrated in Figure 2, we present a pre-training and then post-training paradigm where we divide World Foundation's model into pre-trained and post-trained World Foundation models. To build a pre-trained World Foundation model, we leverage a scale video training dataset to expose the model to a diverse set of visual experiences to become a generalist. To build a post-trained WFM, we fine-tune the pre-trained WFM to arrive at a specialized WFM using a dataset collected from a particular physical environment for the targeted physical AI setup. Yeah, dude, this is what I was talking about earlier as well.
Yeah, so we can do this tomorrow. I was gonna end the stream, but
Uh,
yeah.
yeah, you know
So
what?
basic,
How big is the introduction? How big is the introduction? Go down.
it's pretty big, bro.
No, it's not that big. Maybe we can complete the introduction and then we can end the stream or whatever you say. Like I'm fine with both.
No, bro. I'm gonna start it tomorrow with a
Okay.
fresh mind.
Okay.
I
All right.
want to. Yeah, so this is going to be our plan. Implementing this small project first
Mm-hmm.
and studying the World Foundational Model paper. This is gonna be our next goal.
Mm-hmm.
Let's go! All right, I can end the stream now.